students, today we are going to start the new topic, that is coordinate geometry. All of you are familiar with two-dimensional Cartesian coordinate plane. Here this horizontal axis is known as x-axis, or it is also known as abscissa, and this vertical line is known as y-axis, or it is also known as ordinate. And where those two lines intersect, that point is known as origin. This right hand side of x-axis is positive and the left hand side of the x-axis is negative. Same way, the upside of y-axis is positive y-axis and the downside of y-axis is a negative y-axis. Now let's start our lecture with our first formula, that is known as distance formula. The distance formula is used to find out the distance between any 2 points. Suppose here we have 2 points. First point A, that is with coordinate x1, y1, and the point B, that is with coordinate x2, y2. These 2 points are lie on the Cartesian coordinate plane. Let's say this is the x-axis and this is the y-axis. And if you want to find out the distance between those 2 points, then here we can use the distance formula. Now let's first of all see how to derive the distance formula. Here we have 2 points A and B. This is the distance of point A from the x-axis, and this is the distance of point B A from y-axis, and same way the distance of point B from x-axis and y-axis. So here to find out the distance between A and B, let's draw two lines. One line from A, that is the horizontal line, and another line from B, that is the vertical line. And where those two lines intersect, let's say this point is point C, and this will make an 90-degree angle here. So here we get a right angle triangle ABC. Now if you see this distance, this is the distance of point A on x-axis, and this distance is x1, and same way the distance of point B on x-axis, that will be x2, and same way on y-axis the distance of point A on y-axis will be y1, and the distance of point B on y-axis, that will be y2. So if you want to find out the distance between this point A and C, so here you can see that point C is at a distance of x2 and point A is at a distance of point x1. So the distance between A and C will be equal to x2 minus x1. And same way, if you want to find out the distance between point B and C, the distance of point B on y-axis is y2 and the distance of point C on y-axis is y1. So distance between B and C will be equal to y2 minus y1. So here we can write that AC is equal to x2 minus x1 and BC is equal to y2 minus y1. So here in this right angle triangle ABC, we have find out the value of two sides of the triangle. So here we can find out the length of line AB by using Pythagoras theorem. So here if you use Pythagoras theorem, we can write AB square is equal to AC square plus BC square. So here in place of AC, I can write x2 minus x1 whole square, and in place of BC square I can write y2 minus y1 whole square. So if you want to find out the value of AB, take the square to this side, so it becomes square root. So here we get AB equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. And this formula is known as distance formula. Whenever you want to find out the distance between any 2 points on the Cartesian coordinate plane, you can use this distance formula. Now in this chapter, using this distance formula, various type of question may be asked. Let's see the different types of problem based on distance formula. The first and very simple question is to find the distance between any 2 points. The second type of problem, to check the collinearity of the point. If any 3 or 4 points are given, and if you want to check whether they are collinear or not. Collinear means they are on the same line or not. Then we can use the distance formula. The third type of problem is to identify the types of triangle made by given points, and the fourth to identify the type of quadrilateral made by any points. So in this lecture we will see all this type of problem based on the distance formula. Let's start with the first and very simple question. Find the distance between point -5, 7 and -1, 3. So here 2 points are given. First point -5, 7 and second point -1, 3. And if you want to find out the distance between those 2 points, so here we can use the distance formula. We know the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. So here let's say this first point is x1, y1, and the second point is, let's say, x2, y2. So here in this formula, if you put the value x2 minus x1, so x2 is -1 minus x1, so x1 is -5. So here minus minus become +5 plus y2 minus y1 whole square. So y2 is 3 and y1 is 7. So y2 minus y1, that is 3 minus 7 whole square. So if you simplify it, it will be -1 plus 5, that will be 4 square, that will be equal to 16, plus 3 minus 7, that will be -4, and the square of -4 is plus 16, that will be equal to under root 32. Or you can write this will be equal to 4 under root 2 units. So this is the distance between point A and B, 4 root 2 units. Here we have taken first point as x1, y1 and second point as x2, y2. In place of this, if you take this second point as x1, y1 and first point as x2, y2, then also you will get the same result. You can check it on your own. Okay. Let's see the next problem. So the second question is find the distance between point 24, 10 from origin. So origin means the point will be 0, 0. So let's say this is x-axis and this is the y-axis. This is the point origin and another point will be 24, 0. So here we want to find out the distance of point P from O, that will be origin. So here you can use the distance formula directly. So if you use the distance formula, that is the distance formula is AB equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. So here let's take this is the x2, y2 and this is the point x1, y1. So here if you put the value, that is x2 minus x1 whole square, that is 24 minus 0 whole square plus y2 minus y1 whole square. So y2 is 10 minus y1 is 0 whole square. So this will be equal to under root 24 square plus 10 square. So if you simplify this, 24 square is 576 plus 10 square is 100. So it becomes under root 676. That will be equal to 26 units. So the distance between 2 points is 26 square units. Or otherwise you can use the Pythagoras theorem also. Here you can see this distance will be equal to 24 and this distance will be equal to 10. So if you use the Pythagoras theorem, this is the right angle triangle, then here you can find out the distance between O and P directly using Pythagoras theorem. That will be equal to 24 square plus 10 square. That will be equal to 26. So this way you can directly find out the distance of any point from origin. Now let's see the third question. Find the value of y for which the distance between the points P, that is 2, -3 and Q is 10, y is 10 units. So here 2 points are given. First point P, that is 2, -3 and second point 10, y, and the distance between those 2 points is given 10 units. So if you use the distance formula here, PQ, that is the distance between P and Q, is given 10 units, is equal to under root x2 minus x1 whole square. So let's say this is the point x1 comma y1 and this is the point x2 comma y2. In plus of this, if you take this point Q as x1 y1 and this point P as x2 y2, then also you will get the same result. So here if you put the value of x2 minus x1 whole square, so x2 is 10 minus x1 is 2 whole square plus y2 minus y1, so y2 is y minus y1 is minus 3, so minus minus plus 3 whole square. Now if you simplify this, do the square on both sides. So here this is 10 square, that become 100, and here this under root and square will be cancelled out. So here we get 10 minus 2 whole square, that will be equal to 8 square plus y plus 3 whole square. So here we want to find out the value of y. So let's take this, y plus 3 square will be equal to 100 minus 8 square, that will be equal to 64. So we get y plus 3 whole square equal to 100 minus 64, that will be equal to 36. Now if you take this square to this side, so we get y plus 3 equal to under root 36. So we get y plus 3 equal to under root 36, that will be equal to plus or minus 6. So we will get two value for y. If you take positive value of y plus 3 equal to plus 6, then you will get y equal to 6 minus 3, that will be equal to 3. And if you take the negative value y plus 3 equal to minus 6, so you will get y equal to minus 6 minus 3, that will be equal to minus 9. So y equal to 3 and y equal to minus 9. This is our answer. Let's move to the next question. Question number 4. Find the relations between x and y such that point x comma y is equidistant from the point 3 comma 6 and minus 3 comma 4. So here let's say the first point minus 3 comma 4 and the second point is 3 comma 6, and this point x comma y is midpoint of those 2 points. This point is equidistant from those 2 points. So let's say this first point is A, the second point is B, and this midpoint is, let's say, C. So here if you want to find out the relation between x and y, so here it is given that this point C is equidistant from A and C. So here we can say that distance of point A and C is equal to the distance of point B and C. So if you use the distance formula for distance between A and C, will be equal to under root, let's say this is x, this is x1 y1 and this is x2 y2. So x2 minus x1 whole square, so that will be equal to minus 3 minus x whole square plus y2 minus y1 whole square, that will be equal to 4 minus y whole square is equal to this side the distance between B and C. So let's say this is point x1 y1 and this is the point x2 y2. So here x2 minus x1 whole square, that will be equal to 3 minus x whole square plus y2 minus y1 whole square. So y2 is 6 minus y whole square. So here if you do the square on both sides, then this under will be cancelled out. So here we get, if you expand this, minus 3 minus x whole square, so you will get, this will be equal to 9 plus x square plus 6x. And same way here, this 4 minus y whole square, that will be equal to 16 plus y square minus 8y is equals to, here on right hand side, 3 minus x whole square, that will be equal to plus x square minus 6x plus 6 minus y whole square, that will be equal to 36 plus y square minus 12y. So on the both side you can cancel out this x square is cancel out. Here this y square will also cancel out. Also this plus 9 is cancel out. So if you write down the remaining thing, this is on the left hand side we have 6x minus 8y plus 16, and on the left hand side we have minus 6x minus 12y plus 36. So if we take this right hand side into the left hand side, then it becomes this is 6x. This minus 6x become plus 6x. Here we have minus 8y. This minus 12y become plus 12y. And here this is plus 16, and this plus 36 become minus 36 equals to 0. So here this is 6x plus 6x, that will be 12x minus 8y plus 12y, that will be equal to plus 4y, and will be minus 20 equal to 0. Or if you take 4 common, then here we will get 3x plus y minus 5 equal to 0. So this is the relation between x and y. Or you can write this is like this, 3x equal to 5 minus y. So this is the relation between x and y. So this was the first type of question where you have to just put the formula between distance between 2 points. Now see the second type of problem, to identify the collinearity of the points. Collinearity means either the given points are on the same line or not. Suppose if you have 3 points A, B and C. So let's say this is the point A, point B and point C. If they are collinear, it means they will lie on the same line. So if the point A, B and C are on the same line, so here we can see that the distance between A and B, this is the distance between A and B, this is the distance between B and C. So if you add those two distance between AB plus distance between BC, then we will get the total distance between point A and C. It means if A, B and C are collinear and B is the midpoint, it means AB plus BC will be equal to AC. Or the another condition, it may be like this, the point A, the midpoint is point C and another point is B. So here we can see that AC plus CB will be equal to the total distance AB. So here we can see AC plus BC will be equal to AB. Or the third condition which may be possible is the point A is midpoint. So here we can see that BA plus AC, that will be equal to the total distance between B and C. So that is equal to BA plus AC will be equal to BC. So any of these three condition, any one condition satisfied, then we can say the point A, B and C are collinear. Here if AB plus BC are equal to AC, it means point A, B, C are collinear and point B will be the midpoint. If the second condition is satisfied, then here we can say C will be the midpoint, and if the third condition is satisfied, then we can say A will be the midpoint. So let's say the question based on the collinearity. So let's solve the question based on the collinearity of the points. Here 3 points are given. The first point, let's say the first point A is 1, minus 1. Second point is B is 5, 2. And the third point C is 9, 5. And we have to check whether they are collinear or not. So first of all, we will find out the distance between all 3 points. The distance between AB and distance between BC and the distance between AC. And if the sum of any two is equal to the third, then we can say the points will be collinear. So let's find out the distance between A and B. Here we will use the distance formula. will be x2 minus x1 whole square plus y2 minus y1 whole square. So let's try here 5 minus 1 whole square, that will be equal to, I can write directly 4 square, and here 2 minus minus 1 whole square, so minus minus become plus, so it will be 3 square. So 4 square plus 3 square, that will be equal to under root 25 and is equal to 5 units. So the distance between A and B is 5 units. Same way if you find out the distance between B and C. So here also you can use the distance formula, B and C. So this is x2 minus x1 whole square. So that is 9 minus 5 whole square. So 9 minus 5 is 4 whole square plus y2 minus y1 whole square. So this is 5 minus 2 whole square. So 5 minus 2 is 3 whole square. So this is also equal to 4 square plus 3 square, that will be equal to 25 under root, that is equal to 5 units. If you find out the distance between A and C, so this is A and this is C. So if you x2 minus x1 whole square, so this is 9 minus 1, that is 8 square plus y2 minus y1, so y2 is 5 and y1 is minus 1, so y2 minus y1, so 5 minus minus 1, it will be minus minus plus, so 5 plus 1, 6 square, so it will be equal to 64 plus 36, that will be equal to 100, that is equal to 10 units. So here you can see AB plus BC, that is equal to AC. It means sum of any two is equal to the third. So we can say that point A, B and C are collinear and B will be the midpoint. This will be like this. First point A, this is B and this is C. The distance between A and B is 5 units. The distance between B and C is also 5 units, and the distance between this A and C is 5 plus 5, that is equal to 10 units. So this is how you can find out whether the given 3 points are collinear or not. Now let's see the another type of questions, that is to identify the types of triangle using distance formula. So there are different types of triangle are there. Let's see the first type of triangle, that is equilateral triangle. If you want to check whether the triangle is equilateral triangle or not. So what is the property of equilateral triangle? All the sides are equal. So here we will find out the length of AB, BC and AC. If all three sides are equal, if AB is equal to BC is equal to AC, then we can say that given point will form an equilateral triangle. The second type of triangle, let's say this is an isosceles triangle. So the property of isosceles triangle is that any two sides are equal. So if you want to find out whether the points will make an isosceles triangle or not. So here also find out the value of AB, BC and AC, and the length of any two sides are equal. Either AB is equal to BC, or if BC equal to AC, or if AB equal to AC. If any of these three conditions is satisfied, means we can say that triangle will be isosceles triangle. The third type of triangle, the triangle may be right angle triangle. So to check whether the points will form a right angle triangle or not. So the property for right angle triangle is any right angle triangle will follow the Pythagoras theorem. So Pythagoras theorem is here for this triangle we can say AB square plus BC square will be equal to AC square. So sum of square of two side is equal to the square of third side. So here if the Pythagoras theorem is satisfied, then we can say it will form an right angle triangle. Let's see one question here. Check whether the points 5, minus 2, 6, 4 and 7, minus 2 are the vertices of isosceles triangle or not. So let's say here the first point 5, minus 2, the second point B is 6, 4 and third point C is 7, minus 2. So first of all, find out the length of AB. BC and AC. So if you want to find out the length of AB, here if you use the distance formula, A and B. So x2 minus x1 whole square, that will be 6 minus 5 whole square, that will be equal to 1 square. And y2 minus y1 whole square, 4 minus minus 2. Minus minus become plus, so it will be 4 plus 2, 6 whole square. So it will be equal to under root 37. Same way, find out the length of BC. So here if you use the distance formula, this is x2 minus x1 whole square, that is 7 minus 6, 1 square. And y2 minus y1, so minus 2 minus 4, that will be minus 6 square. So minus 6 square is also plus 36, so 36 plus 1, this is also under 37. So here we get two sides are equal, so we can say that is this are the vertices of isosceles triangle. No need to find out the AC. But still, if you want to find out the AC, you can find out by using distance formula. This is the A and this is the C. So this is 7 minus 5, that will be equal to 2 square plus minus 2 minus minus 2, so it will be 0. So we'll get this under root 4, that will be equal to 2 units. So the distance between AB and BC is same. So here we can say that point A, B and C are the vertices of isosceles triangle. And if you draw this point on the graph, there also you can visualize it. Here let's say these are the 3 points. If you represent these 3 points on the graph, this is the first point, this is 5 comma minus 2, this is the second point 6 comma 4, and this is the third point 7 comma minus 2. So here also you can see this distance between those 2 points are equal, this distance are equal. So here you can see this is also form an isosceles triangle. So this way you can visualize by drawing this point on the graph paper. Let's see the next type of problem, that is to identify types of quadrilateral formed by the points using distance formula. So there are the different types of quadrilateral are there. The first type of quadrilateral is square. So what is the property of square? Yes, the distance between A and B will be equal to distance between B and C, that will be equal to C and D equal to AD. All the four sides of the square are equal, that is the first property. And the second property is diagonals of the square are also equal, means AC will be equal to BD. So if those two conditions are satisfied, then we can say this 4 point will form a square. The second type of quadrilateral, that is a rhombus. So the property of rhombus is that all sides will be equal, but diagonals will not be equal. So if AB is equal to BC is equal to CD is equal to DA, if four sides are equal and diagonals are not equal, then we can say this 4 point will form a rhombus. And third type of quadrilateral, that is a rectangle. So properties of rectangle is that opposite sides are equal, means AB will be equal to CD and also BC will be equal to AD. And the second property is that their diagonals are equal, means AC will be equal to BD. If those two conditions are satisfied, then we can say those 4 points will form a rectangle. And the fourth quadrilateral is parallelogram. So the property of parallelogram is the opposite sides will be equal, that is the first property. AB will be equal to CD and BC will be equal to AD, and the diagonals of the parallelogram will not be equal. So if AC is not equal to BD, but the opposite sides are equal, then we can say this will form parallelogram. So this is how we can check whether the 4 points form any type of quadrilateral or not using distance formula. Let's see one simple question here. Here the 4 points are given and determine whether which type of quadrilateral they form. So let's say this is the point A equal to -1 comma -2, second point B 1 comma 0, third point -1 comma 2, and fourth point -3 comma 0. So let's find out distance between all the sides. First AB and BC and CD, AD, and the two diagonals, that is AC and BD. So if you find out the distance between A and B, this is A, this is B. So x2 minus x1 whole square, that will be equal to 2 square, plus y2 minus y1 whole square, that is also equal to 2 square. So it will be equal to 2 square plus 2 square, that is under root 8, or you can write it is 2 root 2. Same way find out the distance between B and C. So this is B and this is C. So if you use the distance formula, it will be equal to x2 minus x1 whole square, that will be equal to 2 square, plus y2 minus y1 whole square, that will be also equal to 2 square. So BC is also 2 root 2 units. Then the third, distance between C and D. So this is C, this is D. So x2 minus x1 whole square. So minus 3 is minus minus plus 1. So it will be equal to minus 2 square, or you can write plus 2 square. And 0 minus 2 whole square is also equal to 2 square. So CD is also equal to 2 root 2 units. And same way if you find out the distance between A and D, that is also equal to under root 8. So all four sides of the rectangle, all four sides of the quadrilateral are equal. So it may be either it may be square or it may be rhombus. If the diagonals are equal, then it will form a square, and if diagonals are not equal, then it will form rhombus. So let's check the length of the diagonals. First diagonal, that is AC. So this is A and this is C. So x2 minus x1 whole square. So minus 1 minus 1, that is 0. And y2 minus y1 whole square. So 2 minus 4 square. So AC is 4 units. And same way to find out the length of BD. B is 1, D is minus 3. So minus 3 minus 1, it will be equal to minus 4 whole square. And the y2 minus y1 whole square, that is 0 square. So this is also equal to 4 units. So here you can see the length of all four sides are equal and diagonals are also equal. So here we can see those 4 points will form a square. So this is how we can find out which type of quadrilateral formed by any points. So these are the different types of questions that may be asked based on distance formula. In the next lecture, we will see the another formula, that is section formula.